Dear students, how are you? Hopefully you are well, and this is your second lecture on geometry part chapter 8, and this topic will be totally depending on your chapter 8, and this is your lecture number 3. And today we are going to discuss about chapter 8 and 25, 26 and 27 number math. Okay, so our first number theorem says the tangent drawn at any point of a circle is perpendicular to the radius through the point of a contact of the tangent. So the question says the tangent drawn at a point. So we are trying to draw a tangent which must be at a point of a circle is perpendicular to the radius through the point of contact of the tangent. Okay, so here the spatial nomination says suppose PT is the tangent which actually we are trying to draw at the point P to the circle with center O. So PT is our tangent. This the PT is drawing tangent, and this tangent is drawn at the point actually P with the center O. So the circle center is O, and OP is the radius of, so OP is the radius through the point of contact. So this point, this is the point where we are drawing a tangent, and this is the point where we are drawing the radius. It's required to prove that PT is perpendicular on OP. PT, the tangent, is perpendicular on OP. Now the construction part says take a point Q. We are just take a point Q on PT. So we are on that PT plane. We are take a actually point Q, and OQ must have to be joined. Now our proof part. Proof part says since PT is a tangent to the circle at the point P. So since yes, we have been already talked about that P is the point where we are drawing the tangent PT. Hence, every point on it except P lie outside the circle. That means since this is the point where we are trying to, or where we are actually going for the circle, and also we are drawing the radius, so any point on this tangent will be actually outside the what? Circle. So Q also actually outside the circle. So the point Q is also outside the circle. If Q is outside the circle, then what about the distance of it? So the distance of OQ is greater than OP. The distance of OQ is actually greater than OP. It is true for every Q on the tangent PT except P. So at actually on PT, if we are taking any point that must be outside the circle except P, only P is the point who will be the point of contact. That means this P will remain the circle. Okay, so OP is the shortest distance from the center to PT. So PT is the shortest distance, and since PT is the shortest distance, since PT is the shortest, OP is the shortest distance on PT, that's why we can say the OP is perpendicular on PT. So here in this question, in this theorem, we have to observe two things. First thing is P is the point of contact where we are drawing the tangent, and P is the point where we are drawing the what? Radius. And here the radius part, or the, since this is the point of contact, that's why if we are taking any point on Q or PT, that must be lie outside the circle. That means the distance of OQ or something like that, or like Q related distance must be bigger than the OP. So OP is the smallest distance, and since OP is the smallest distance, that's why we can say OP is actually the perpendicular on OP. So the PT and OP will be remain perpendicular. That means they are creating a 90-degree angle. Okay, thank you. So this is our theorem number 25. So here this is the theorem number 26, and theorem number 26 says if two tangents are drawn to a circle from an external point, the distance from the point to the point of contact are equal. Okay, so here some important part is given, that is two tangent we have to draw from where? From an external point. The distance from the point to the point of contact are equal. Okay, so here let P be the outside of the circle. This point is, yes, this point is outside of the circle with the center O, and there is a circle named AB, maybe C, with the center O, and two line segments PA and PB be two tangent. Here PA and PB, these two are the two line segments, and these are two actually the tangent. So, and actually these two tangent actually on the circle A and B touches the point, 2 point A and B. It's required to prove that these two sides are equal. Okay, construction. At the case of construction, we have to go for some addition, that is OA, OB and OP. We have to add these 3 points, OA, OB and OP. Now we are going for the proof part. Since PA is a tangent, OA is the radius through the point of tangent, PA is perpendicular to OA. Here actually our OA is the radius, what happening here? Is the radius and PA is the tangent, and according to the theorem of 25 we know the tangent and the radius must be the what? Parallel to each other, perpendicular to each other. That means there will be created a 90-degree angle, isn't it? So since PA is the tangent, OA is the radius, so PA is perpendicular to OA. And since we can say that this A angle is equals to 90 degree, or PAO is 90 degree, similarly PB is also 90 degree. Here we can say that POA and POB, these two triangles are right angle triangle, and in this right angle triangle we can say these two sides are equal because of the radius, and these two are equal because of same length as well as the hypotenuse of this triangle. And since we can get two sides are equal, then we can say two sides are equal and also this angle is 90 degree, then we can say these two triangles are congruent. And since these two triangles are congruent, we can say that PA, that means this part, is equals to this part. So here the angle are 90 degree and these two triangles are right angle triangle, and finally in the right angle triangle these two triangles where the hypotenuse are equal, because this is the same side, and also the radius are equal, that's why these two triangles are the congruent. And since these two triangles are congruent, so all sides are equal. On that sense we can say these two are equal. Okay, so this is the last theorem for this lecture. This is the theorem number 27, and this theorem number 27 says if two circles touch each other externally, so two circles must have two touches externally. Okay, the point of contact of the tangent and the center are collinear. So the centers and the point of contact of the tangents, these two are must be the collinear. So whose are the collinear? Collinear must have to be the tangent and the center of the circle. Okay, special nomination says let two circles with center A and B touches each other externally at O point. So suppose here is a circle. In this circle the center is OA, and in this circle the center is B. So these two actually circle the center of A and B actually touches each other at the point O. So the circle having center A and the circle having center B touches each other externally at point O. Okay, so it's required to prove that AOB are collinear. So we have to actually prove that the AOB are collinear. That means these are remain in the same line. Okay, so now our construction part says, since the given circle touches each other at O point, yes, the touches each other at O point, they have a common tangent at the point O. So they have a common tangent, that is PQ, at the point O. Draw the common tangent POQ. Draw the common tangent POQ at O. So at the point of O, we have to draw a tangent POQ. And here join OA and OB. So join OA and OB. So what actually happened up to this part, I wanted to go for the re-summarization. That is, there is two circles. First circle is A, another circle is B, where the center of the circle is A and this center of circle is B. In these two circle actually touches a point O, and these two are actually touches externally at point O. So since this point is our touching point, so from that point we can draw tangent, and that's why we are going for a tangent POQ. Here just talking about that, so we have to go for POQ tangent at O point, and also we have a drawing that is join AO and OB. Now in our proof part, in this proof part there is talking about a circle. AO is a radius, and POQ is the tangent. POQ is the tangent. So we are just thinking about this triangle, this circle. In this circle, A is the center and AO is the radius and POQ is the tangent. Okay, for that reason we can say it has actually create a 90-degree angle here. So POA is actually 90 degree. Similarly, if we are going for this circle, here actually given a center B and OB is the radius and POQ is the tangent. So we can say POB must be 90 degree. So you may write similarly. Okay, now if we are just adding these two parts, so POA plus POB, so 90 plus 90, that means 180. Okay, now the POA, that means this angle, and POB, that means this angle. So what actually this angle, that is must be AOB. So we, at the place of POA plus POB, we can write AOB. Now if it is AOB, then AOB is a straight angle. AOB is a straight angle. Since POB is a straight angle, that's why we can say that is 180 degree, and since AOB creates an 180 degree, we can say AOB is nothing but a collinear. And what we have to actually prove, so collinear, that means they remain the same line, and that's why we are going for AOB is the collinear. Okay, I wanted to go for this re-summarization for this theorem. That is, first of all, we are going for this triangle where the center is A, and this triangle center is B. These two actually touches each other, and they are touches each other externally at O point. Now we are drawing at actually a tangent, that is POQ, and this tangent actually perpendicular to this radius. So we can say the radius AO and PO, this creates an angle 90 degree. So the angle AOP is equals to 90 degree, angle POB is equals to 90 degree. If we add these two angles, then it will be AOB angle equals to 180 degree. Since it is 180 degree, then we can say this is nothing but a straight angle, and since it is a straight angle, we can say that AOB is a collinear. So that's how we can solve this theorem number 27. And that's all for today. Hopefully you are keeping touch with your study, and please stay home, remain safe. But important thing is your exam is very much knocking at the door, so be serious. Thank you.